Hello. I'm audible.
Hello. Yes, you are.
Screen visible, na?
Yes, sir.
Okay, so see, today we'll do a manual RCC designing in STAAD Pro and one foundation, that isolate foundation. Okay, so see, first take a new project, select a space and RCC design. Then location is same, length unit in meter and force unit in kilonewton. Next, yes, and then finish. Close the grid. Okay, now just pick step 1 from geometry, run structure wizard, and take a frame model. Length is 12, height is 15, and width is 12. Okay, apply, transfer model. Yes. Now see, we provide a floor also in this structure. So for floor, see, we have one option here, fill floor grid with plate. So for use this option, fill floor with plate, we have to select all the X and Z axis beam. So go to select beam parallel to X axis, select beam parallel to Z axis. Then just click on fill floor grid with plate. Now see how many plates we get. 80 new plates are created. Okay. Now see in 3D render, see floor plates. Okay. Then just go to general for section property. Define a beam and column size first. 0.30, 300 mm, and width is 0.230 mm for beam. And for column we use 0.30, 300 mm by 300 mm for column. Then for plate, see, for plate thickness we use this option, thickness. Okay, just click on thickness and see in thickness we have two elements, a plate element thickness and surface thickness. So we give a plate element thickness, and that is 0.120 mm. A concrete material. Add loads. First, see, I just assign a plate thickness. So for plate thickness, just select the plate cursor, select all plates, then click on assign R3, that is the plate. See the plate thickness. Okay, the next is beam. Select beam, go to select beam parallel to X axis, select beam parallel to Z axis, assign. Then for column, select Y axis, select beam parallel to Y axis, then assign. Then next, support. Click on support, create support, add, select support, go to front view, select all the nodes and then assign. Then next options to assign load and definition. So for load and definitions, we just go to load and definition option, add load case, select load case detail, add dead load, EL, live load, double L, chain load, live, double L, second number load. Done. Select dead load, add one first self weight load, then member load, and we assign member load as a uniform load. So just give minus 14.72 kilonewton. Last class load, this one 9-inch wall. According to 9-inch wall, we give minus 14.72 kilonewton on beam. Add. Then next we need a plate load also. Pressure on full plate, because we have given a plate in this structure. So for plate, we have the same options to calculate plate load, weight into density, and concrete density is 25. So we have to take length into width into height into density of concrete. So when you calculate, you get about minus 3.2 or minus 3 kilonewtons. So I just give here.
Self-weight
Yes.
sensor will not do for.
Yes, good.
If you select self-weight.
Yeah,
self-weight,
I give the
that can
self-weight
do, no?
first. Yes. Then plate load we give minus 3.2 kilonewtons in GY axis. Global Y axis, then close. This is a dead load plate. And then next, in live load, we add a floor load, that is minus 3.5 kilonewton, that is standard load. And we have to give a range, and our structure range is about 15 meter in Y axis. Add close. Sorry, we have also modify give the range in X axis, that is 12 meter, and in Z we have 12 meter width, and change close. Select the self weight, assign to view on structure. Then for member load, we assign on beam. So for we have two side beam, X axis and Z axis. So click on select beam parallel to X axis, select beam parallel to Z axis. Select assign to selected beam option, assignment method, then assign this value. Okay. Then for plate load, we select a plate cursor and select all the plates, and then select assign to selected plate and click on assign. Done. Then now analyze, add, close, analyze, run analyze, then save. Okay. Next, after analyze, see, we get one new load type here. Apply, okay. See, we get a plate option here. So in plate, we see the stress on plate. Okay, when you click on plate now, if I click on plate, see, stress type we have to see as a maximum absolute stress on plate, apply, and okay. See, these are the stress on plate. These are the readings. And see, if you click on plate in animation, see, click on deflection. Where is that option? Scale plate stress level, maximum absolute. Then go to deflection, click on stress, apply, then okay. So it will display the stress, and see, we have the normal stress on y-axis, local y-axis, and local x-axis. We have the normal stress on plate. Okay. So after analyzing and after seeing all the deflections, all the shear force and bending moment, all the graphs on beam, we have to design with RCC, a manual design. Okay, you have seen the automatic. Na? Automatic will do with this option. Click on design and go to concrete, and from here current code is IS456. Click on define parameter. This is an automatic RCC design. Click on FC. FC is a compressive strength of concrete, that is 25,000 kilonewton per meter square. Add. Then second one is FI main, that is yield strength for main reinforcement, and that is 415 or 550. So we give first value that 415,000 kilonewton per meter square. Add. Then we have also one option here, track. Track means result options. We get the results according to track. See, we have three options here. In first, if you select 0, then you get a limited detailing about reinforcement. So I select a last option. So we get the maximum results. Add, close. See, we have added FC, FIMAN and track. Then go to command and give command to design. So we select design beam, add, design column, add. Now we have design slab also. So select design slab and element, add, then take off for complete the command. Take off, then add, close. Okay. Then next we have to assign these all parameters. So select FC and assign to view on whole structure. Then select FIMAN, that is yield strength of steel, assign to view on whole structure. Track also assign to view for whole structure. And now for beam, we have to select beam, and we have two side beam, X and Z axis. So select design beam, go to select beam parallel to X axis, select beam parallel to Z axis. Then see, assign to selected beam, assign. Then for column, we have in Y axis column in vertical. So go to beam parallel to Y axis. Assign to selected beam, assign. Then next, design element. So for design element, select plate cursor and select all plates, then assign. Okay, done. This is the automatic design according to IS 456. Then go to analyze, run analyze and save. Done. Go to view output file. In view output file, we get all the beam detailings in X and Z axis. If you select the concrete design, now see, we have this beam number 1, and in beam number 1 we have this range, and these are the see here, in top reinforcement, bottom reinforcement, from 0 to 3000 mm means 3 meter, 0 to 3 meter. We have this type of 2 number of bar at 10 dia. Okay, 2 number of bar at 10 dia in top view, and in bottom we have the same 2 number of bar at 10 mm. And stirrup is about 8, that is 100, distance is 110 mm, 8 mm dia of stirrups. In second number beam, okay, we have the same bars in all the beams. Yeah. And see, for column, if you want to see in column, just select any single column, top view column, go to concrete design. So we have bar size is 12 and the bar number is 4. We have 4 bars at 12 mm dia in column. If you see the last one, okay, same here, bar size is 12 and bar number is 4 now. Okay, so this is a manual automatic design. Okay, this one is as a automatic, and we have one options for manual. See, if you have calculated quantity of bar or bar dia, so you can do a manual design also. From here, see where it is, RAM connection. Yeah, this one, concrete design. This option is a manual. So if we have any readings, any manual calculation, you can design RCC with this option. See, just click on concrete design. Okay, concrete design. See, we get one separate software of StatPro, that is RCC Designer. Now see what we do. First, we have to create an envelope here. Okay, first we have to do envelope. First, see, we have job information. If you want to give any job information, client name, job number, part and reference, name of engineer, checkers or approved, date, timing, any comments about this structure. Then second, we have to create envelope. Envelope means, see, we have elements here, beam and column. So we have to create first envelope for manual. So first, see, create envelope. For in manual designing, first step to create an envelope. So see here, first you click on new envelope. First click on new envelope, E1. So E1 we give as a beam. Okay. See, when you click on OK, so it will show us load type, how many load you have assigned. So we have to give a load case also in this envelope in beam. So uncheck this option. So we'll see. Buttress. Okay. See, when you uncheck, so we'll see that loads, dead load and live load. Just drop here at this side in envelope. Then see, we have envelope one is beam and load type is dead load and live load. Click on OK. So we get first envelope, then second envelope for column. E2 is about columns. Okay, and in column also we have two load, that dead load and live load. So just drag in this envelope option, then click on OK. Now see, we have two envelope here, beam and columns. Then next step is to go to members. Just click on member, and in member we have to create a group for beam and column. So first, just I click on this screen, go to front view, because see, there is no shortcut for selection, so we have to select manually. So go to front view and select first beam. Press control for multiple selection. See, after envelope, go to members, select beams. See, in 3D all beams are selected. Then go to member option from menu bar. See, in members, just click on members, and see, we have one option here, auto form members. Click on auto form members. See, they will create a group for beam, a separate group for beam. And then next column, again front view, select all columns, press control and select all columns. Go to isometric and see all columns are selected. Again from menu bar, go to members, auto form members, and then see, we get the column group also. All column groups, member 1, member 2, member 3 will specify that group. Then next we have option for group and briefing. So click on group and briefing, and in group and briefing we have to create a new brief for column and beam. See, just go click on new brief, and B1 is a beam. B1 is as a beam, and select design code IS456, and design type we have two, beam or column. So first beam, then click on OK. See, when you click on OK, so we get a manual setup here for minimum cover, minimum reinforcement spacing, concrete grade, okay, and divide a beam into 12 segment. 12 segment means stirrup segment, 12 stirrups there, dividation of a beam. So minimum cover, it will give us 25 mm, side cover is also 25, bottom also 25. So if you want to change it with 30-30 or 20-20, so we just give a manual readings here. All the then next minimum spacing of reinforcement, we have 40-40 mm. Then concrete grade, if you want to change, we have 20, 25, 30, 35 and 40. If you want to change with concrete grade, just select from here. And then we have to see this is a general properties of the clear cover and reinforcement spacing. Then next option is to mend reinforcement detailing for top bar crate area and for bottom bar crate area. So see, a minimum bar size, maximum bar size. We have two types, minimum size and maximum, and link hanger size. Means this one is stirrup, that is 8 mm. Okay, so first we have to change this minimum bar size. So if we have calculated some bars, suppose I need a minimum from, suppose I give from 10 to 16. Suppose I give minimum 10 mm bar to maximum bars size is 16, and in bottom also I just give 10 to 16. Link hanger is same as 8, and minimum gap is 32 mm. Minimum gap is 32 mm. And see, we have yield strength of steel here, Fe 250, Fe 415, Fe 500. So we select Fe 15 for this design. We have side bar criteria here. So we give as a minimum size is 10. Then go to shear reinforcement, and in shear reinforcement we have shear bar criteria here is 8, and shear bar type is Fe 215. Minimum number of leg we have 2. See, we get the options for legs 2, 3, 4, 5, 6. How many legs you need for beam? Suppose we need this time only 2, and minimum spacing is 40 mm. Okay, these are a manual setting. If you have any calculation, so we can put that value here. For clear cover, reinforcement spacing, divide bar beam into number of segments, then minimum bar reinforcement for top, for bottom. Okay, and that yield strength for reinforcement, and then shear reinforcement. Madres, भाई बंद कर लो यार mic. Then next, see, do okay. After all the parameters given, we just add here. See, we get the beam with IS code 456. All the manual reading we have filled. Then next, we have to create for column new brief. B2 column. Design code IS 456. Design type we have to change as a column. Okay, IS 456. Then column. Click on column. Now see, in column we get a general information for concrete. It's M20, M25, M30, M35. If you click here, you get all the grades: M20, M25, 30, 35, 40. Okay. Then main reinforcement spacing 40 mm. Clear cover at 40 mm. It will give a 40 mm for clear cover. Main reinforcement bar is Fe 15 for 15, and link is Fe 250. Link means for stirrup, and the stirrup size is 8 mm, and main bars at 12 mm to maximum bar size we give maximum to 16. Then go to column factor, and in column factor we have to specify that our column in YY axis. Okay, braced in YY axis because it's a vertical shape, so we give YY axis. Then member load case, we have two these loads, so just select and drag this side, then click on okay. So after creating this brief, we have given all the manual readings here. We have to create a design group. So for design group, see, we have again go to front view, and see, no need to click on this new design group. Okay, we have to select first beam. We have to first select all the beams. Then go to 3D view. Just right click. Then just we have to click on new design group. Okay, after selecting all beams, okay, go to front. Select all the beams for a new design group. Select all beam, isometric, then right click and just click on new design group option. New design group 1 is as a beam. Click OK. See, we get first group here. Click outside, again front view, select all beams. Isometric view, right click, new design group. Next is column. Design group 2 is as a column. Okay. Done. Then next, after group and brief, go to concrete member option. Concrete member option. And see, we have two group here. G1 for design group 1, that is beam, and G2 as a design group 2 as a column. So we first select a beam. Now see, all beams are failed now for this time because we have not given any command to design. So next command is to click on design here. See, after summary, these are the summary. Next option is design. So design group 1 is selected. So click on design and see, we have all the beams here. We have how many beams total? Total 50 beams we have. So just simple click on beam. Click on design. Now see, all designs are okay, all passed. Then see, if you want to see the main layouts, see we have option here, main layout. In main layout we get all the detailings here about beams, which beam you have selected, so we get all the detailings in this beam. Main reinforcement, so we have the reinforcement, fogging, sagging, side, link size. Okay, and see, now see, I have selected 10 to 12, so it will provide a 10-10 reinforcement in beam. In all beam, we have two beams with a 10 dia reinforcement in all beams. Shear layout, we have shear layout, shear reinforcement details. Then we have schedule. In schedule we get our drawing, this type of drawing, and we can easily open this drawing in AutoCAD and we can make any modification in it. For detailing purpose we use this drawing. See, we have a single beam, but we have 1, 2, 3, 4 sections, and here we get 3. So if you want to divide this beam in a section in span, just check these options and we get a 3 span. And see, export format in DXF. DXF means this file will open in AutoCAD. So click on OK on desktop, RCC design. Beam. Save. Then next for our design group 2. And design group 2 we have column from 51 to 175 total column numbers. So next select the design group 2, click on design, and all selected column, just click on design. All column also passed, we get OK from StatPro. And now see the main layouts of a column. See, these are the deflection, column elevation, and their plan. We have 4 bars. Then see the shear layout. These are the shear layout, shear reinforcement layout. Result, we have results. 4 bars at 16 dia in column here. In all column we have 4 number of bars 4 and 16 dia. We specify 16 dia in all column. And we have schedule for column also, section and plan we get 6 centimeter A4 size in DXF format. Okay, this one is for column. So this way we do a manual RCC design for column and beam in StatPro. Okay, after analyzing, we have to choose this option, select this option, concrete design, and we get a separate application here for RCC designing.
Sir,
Yes.
Stanford check that percentage of steel or not.
Passing.
Percentage of steel in concrete. Steel
Yes.
percentage. Is it
Still,
checked?
yes, still percentage. It will show in automatic only.
No.
Still percentage. I have done. See here. If I select any column, I have to do automatic also. So in concrete, in column we have percentage of steel is 0.50. Will show.
So it is
And
the
the
failure, sir. 0.8% is the minimum, sir.
point.
8% is the minimum
Yes.
in column.
Hmm.
Sorry, 1% is the minimum in column.
Hmm.
We should provide 1% steel.
Yes.
It, as per IS code,
Hmm.
column we should provide 1% steel minimum,
Hmm.
whereas
Minimum.
it's provide only 0.5%. Sir.
Hmm.
So it's not the proper design is done.
So what we do, we have to change the column size.
No, sir. Can I provide percentage of steel at the time of design?
No.
No. Okay, sir.
Can we go on?
But actually, sir, minimum column design column size should be 0.3 by 0.3 as per
Yes,
IS.
300 mm by 300 mm.
300 mm.
Hmm.
Then we should provide more steel.
Hmm.
Then, sir,
I
it is
think what he's saying, minimum
not the
reinforcement should be
proper way.
0.85.
Yes, please. Then, sir, design is done not in proper way.
Okay, so you just practice this thing. Okay.
Okay.
Now just practice. Okay. After practice, I will show you for our foundation designing.
Excuse
Isolated
me.
foundation.
Can,
Yes.
can you explain these groupings on Connect version? How to make this group on Connect version?
Connect version.
Yes.
Group in means in RCC designing.
Yes. Yes.
You will just try this concrete design automatic and see will get 1% or not. Okay, I have actually selected all random size for column and beam and load also. I am not calculating manually how much load we need to assign. Now, who is asking for connect addition?
Yeah, I was asking for Connect.
Yes, yes. In connect addition, RCC design.
And I would like to see the results for the plates also.
Connect addition. Yes.
Sir,
Yes.
class is over or not? It is for
No, no, not over. We have one more topic on foundation design.
then please
Actually,
go through.
I'm searching RCC manual designing for Connect Edition. I didn't get any tutorial on manual. There is automatic is there.
Sir, let it check later, sir.
Yes, yes.
Please go through. Uh,
Okay. So practice.
it is four-story building. We should design with seismic. Then load combination should be done.
Hmm.
Load combination with seismic load.
Hmm.
As per IS, near about 8 combination to 16 combination, so on. Sir,
Hmm.
can I see the system?
For combination
Load
or
combination
seismic.
for seismic, sir.
Okay. So you are absent in I think last class, no?
No, sir. Sir, I was absent, sir.
Okay.
If you please provide the video, it should be
Yes.
better for
No
me, sir.
problem. No problem. I just repeat that. So now see the foundation design also. Okay.
Okay, sir.
See the isolated foundation design. After analyzing all the loads and designing, see we have these options for foundation design. So click on foundation design and see we get this tab here as a foundation design option. And whatever you have assigned the load na seismic, wind or combination, so we get all that load here, available load case. So through which load case you want to design foundation. Suppose I just select all the loads like dead and live, include all. Just click on include all for adding all this load. Include all. Then click on run instead foundation. Could not open it. Why? Just I just analyze this structure once. Analyze, run analyze. Okay, done. Okay. Go to foundation design, include this load case, run is. Okay. I just first save this project. I think I have to reinstall this software because when you analyze the structure, no, it will automatically when you click on run instead foundation, it will automatically on foundation designing, but this time it's not working. So I have opened the state foundation separately here. I think this is a 4 series state foundation. I have to install 6 series. So what I do, I just save this project. I use save as option. Save as. Just save this desktop. RCC design. Save this project. STAAD Foundation, new file. Desktop. STAAD. RCC. Okay, I think it's not working, so I will just reinstall this one and I'll show you foundation design tomorrow. So now see, restart program. Cancel. Now see about a seismic load. I just repeat it again here as a seismic load and combination load. STAAD Pro. New project. Earthquake meter. Next. Something is happening. Error. And next select the code object to not. Then go to top view or pick some structure from run structure wizard and structure frame model. Suppose I need a building height of 30 meter with 10 step with 3 meter spacing and length is okay 12 meter. Apply, then transfer this model. Yes. In isometrics. Okay, now go to general for a property. Define property rectangular column. We use 400 mm and 400 mm for column. Then next for 350 mm, 350 mm again for column. Then 300 mm and 300 mm for next column. So I have given 3 categories of column. 400 mm I just assign it this portion 1. 4, 5, 6, 7, 10. So at 4 I just assign 400 mm. Assign. Yes. Then 350 I just give it this portion. Fine. And 300 mm at this portion. And assign. Okay. Now for beam, define a beam, rectangular beam. 0.3 to 0.250. I just give us a single beam. Go to select beam parallel to x-axis, select beam parallel to z-axis, and assign this property. Then go to support, create support, fix support, add, select, go to front view, select all the nodes, assign. Then go to load and definition and see before assigning any dead load, live load or wind load, we have to assign a seismic load. Okay, and because seismic load is always calculating from bottom to top, so that's why we have to define first seismic load here. So see, we have to first create a definition. So click on definition and go to seismic definition, add, and from here we have to select first type. So we use, see in series 6 we have this code Indian IS 1893 2002 2005. Select that type, Indian IS code. Then see we have to give some answers here about this parameter: zone, response reduction factor, importance factor, rock and soil factor, okay, type of structure, damping ratio. See, we have our damping ratio of 0.05. It will show as a zone. I think this zone is 0.075. Yeah. So see, just click on generate for generating, for selecting the zone and response reduction. So see, we have a type like CTs also. We have two types of zone factor like CT or zone. So if our structure is as an industrial, so we select zone. Yeah. If our structure is a residential, so we select a CT according to CT. So see, in zone we get all four type zones: second, third, fourth, and fifth. Suppose if we select fourth zone, so we get a reading of 0.24 in fourth zone. If we select a fifth zone, so it will show us 0.36 as a zone factor. So suppose we select a fourth zone, and that is 0.24 factor. And response reduction we have to see as the ordinary RC moment restressing frame. That is reinforcement concrete moment resisting frame. That reading is 3. Then we have to give some important factor about this building. It's a important building or all general building. So suppose if you give important building, so it will increase safety factor of 5% is there, 1.5. And if you select all general building, it will give only 1 safety factor. So important means like school, colleges, so or hospitals. So suppose if I give a important building as factor 1.5, then we have to give some other parameter about soil and rock. See, a rock and soil types. So we have 3 types: hard soil, medium soil, or soft soil. So I just give a medium soil. And what is the structure type? Structure type is RC frame building, that is reinforcement concrete or steel or all other buildings. So I give a RC frame. And damping ratio we use 0.05, 0.05 percentage. And see, for if you have using a foundation, so you have to specify the foundation depth. What is the foundation depth of the building? So 3 meters. Suppose if we give 3 meters, then click on generate. So according to generate, we get all readings here: zone, the response reductions, important factor, damping ratio. So click on add to add this definition under seismic. Then self-aid factor we need 1. And see, we have some question here like member weight, floor weight. And suppose if we have calculate as a uniform load, as a member load, if we have calculate the wall load, beam load, so we give that calculation value weight here. And suppose we give 20 kilonewton as a uniform load on beam, add. Then for floor load, suppose we give as a floor load minus. In earthquake load, we have to assign positive value. So suppose I give 8 kilonewton. Building height is about 30 meter.
30.
Yeah, and in X we have 12 meter length and 12 meter. add, close. Now see, we have to assign this uniform load. So go to select beam parallel to x-axis, select beam parallel to z-axis, then select assign to selected beam method, assign. Done. Then after the definition, we have to add a four-sided load, a four-side seismic load, all the four side x and z, and positive x and positive z, negative x and negative z, because we have four-sided of this building. So click on load case detail, add. First, select seismic load type seismic, specify name that earthquake in x positive axis, select Control C for copy, add Control V in negative x, then Control V in positive z, Control C, add, then Control V with negative axis, select x positive, add, and select seismic load, direction is x-axis, factor is 1, add, close. In negative x-axis we give our negative factor, seismic load x direction but factor is negative, -1, add, close. Earthquake in z-axis in positive, so direction is z and factor is also in positive, direction z, factor 1, add, close. Earthquake in z negative axis, go to seismic load in z direction but factor in -1, close, done. Okay, after the seismic we have to give dead load and live load also. So save, select load case detail, add dead load, that is DL, add second live load, double, close. Select dead load, add self weight first, that is in -1 factor. Member load we have given 20, so in dead load we give -20 kilonewton, add, close. And for live load we have given 8 kilonewton on floor, so select floor load. Now we give -8 negative value at 30 meter height, 12 meter width in x-axis and 12 meter in z-axis, add, close. Select self weight, assign to view, select member load, and member load we have to give on parallel x-axis and in parallel z-axis, all the side. Select assign to selected beam, assign this property load. Okay. Done. And see how many load we have. We have seismic, dead load and live load. See, I have picked some combination load for earthquake, wind load, and for dead and live. 1.5 I am using for dead and live load, and for earthquake, first combination is 1.5 for dead plus earthquake, and second 1.2 for dead, live, and earthquake, and third is 0.9 for dead load and earthquake. So according to this code, we have to generate only 4 here, 1, 2, 3, 4. But after generating this 4 load, we get total combination of 4, 12 and 13. We get 13 load combination. It will generate 13 load combination. 4 side in earthquake, because in this combination we have earthquake and we given a 4-sided earthquake, that x positive, x negative, z positive, z negative. In this combination also we have earthquake, and third we have earthquake. So see where we fill this combination in StatPro. Just go to command and see we have these options, loading options. Click on loading, go to auto load rule, edit auto load rules. see we have the first rule here. See, if you select first Indian code, and according to Indian code, see we have some default combination here, but I want to create that combination, 4 type combinations. So for that, first click on new category. Click on new category, specify name like DL plus live load plus earthquake load. And number of rule I need this time of 4 rule. One for dead live, second for dead and earthquake, third one is for dead live and earthquake, and third one is for dead load and plus earthquake, that is 0.9. So I need 4 number of rule this time. Okay. Okay, so 4 number of rules. So first rule we have 1.5 for dead and live. So we give 1.5 for dead and 1.5 for live. Then second rule we have 1.5 for dead and 1.5 for earthquake. 1.5. Uncheck this, check seismic load, uncheck this snow load. So we need these 3 combinations: seismic, dead load, live load. So yes, dead load, earthquake. Then second 1.2 for dead load, live load and earthquake. So 1.2 and 1.2 and 1.2 for seismic. Then last we have 0.9 for dead load and earthquake. So 0.9 and 0.9. Then after fill up these readings, we have to click on update table. Click on update table. So we get update table under Indian code, dead load, live load plus earthquake name. This is a category. Then close this. Okay, so where we get this combination, just click on load case detail, click on add. See, first we have the primary loads. Primary means we have this all primary loads. The last one we have auto load combination. So click on auto load combination, select load combination code, and we have used Indian code where it is Indian code. And the combination category we have given a name, that is dead load plus live load plus earthquake. Okay, after selecting the load combination name and code, just click on generate load. Now see, according to that 4 load, we get a 13 combination. According to that 4 rules, we get the total 13 combination. Just add this combination here. Then close. We get all combination. Then go to analyze and print, add, close. Then go to analyze, run analyze, then save. Done. Then go to post processing, apply. Okay. So see, we get all loads here. In this type, we get all load type like x-axis, positive x-axis deflection, displacement, or negative x-axis displacement, or positive z-axis displacement to earthquake, or to combination load, dead load, live load, or dead load, live load, or with earthquake load deflection. So if we click on see, if you want to see a deflection, displacement result, so click on result and view value, go to beam result and activate this maximum displacement. Click on annotate, so we get this 500.855 mm on top. And see, we can't move this text in with the text cursor. This one, which one, geometry cursor. Go to result again, view value, go to beam result and check this value. Go to animation, just activate this deflection option, apply, okay. See, in combination or in x positive axis deflection, x negative axis deflection, and Z positive. This is the earthquake effect on this structure in Z axis. If we click on beam, so we can see that bending in Z axis or bending in Y axis. These are the bending in Y axis, and it will show you the summary also how much it's deflecting Y axis, minimum and maximum bending. We have the shear also, shear force in Y axis, and we have again the options to view that value in shear, in maximum shear force or maximum bending moment. Annotate that is minus 0.19 kilonewton at bottom and 20.008 kilonewton at top. In bending, we see in bending minus 301.906 kilonewton per meter. Result view file, wall close. In stress, we have the stress type of beam stress. All stresses are on this bottom portion in column and beam. See, in modeling in general also we have options to see the deflection. Go to load case detail, earthquake in x-axis, z-axis, minus or positive or negative. See, if you select in x-axis, so it will show you through the arrow, and we have these options to show the deflection. If you click on it, see that green portion will show us deflection at this side. In z-axis, in minus z-axis, Z in positive side and Z in negative sides. This deflection through combination. So these are the method to generate a combination, and this is the auto combination. If you want to put a manual combination, there is the options for manuals. So select load case detail and see we have this define combination option here. This one is automatic. If you have put the auto rule combination in command, and we have the define combination also. So we have options to define that combination manually here. See, we'll do concrete also, concrete design on this. IS 456 define parameter FC, that is 25. Add FY main, that is suppose if I add and track options for a result, track, add close. Go to command, add beam, add column, take off. Select FC, assign to view. FY main, yes.
Can we go for slab design also?
Yeah. Select beam, go to select beam parallel to x-axis, select beam parallel to z-axis. Okay. Assign, then column. Select beam parallel to y-axis, assign. Now see analysis result. Save. Oh, it gets out of warning. Yeah.
How to cover this warning and errors?
First, we have to understand what is this warning, so then we can solve this. You see, go to view output file, done, and see what is warning first. Okay, some sections properties are failed here for concrete designs. Which property? Warning section fail while designing section 0.0 mm. Why? 550, 415. It will not providing a reinforcement in these beams. The beam one is failed. According to reinforcement percentage is exceed. Oh. Yeah, the percentage provided 2.51 this time. And the bar size is 12, bar number is 20. It will provide 20 bar bottom. There is no designing, so it will fail some of the columns there. Three 3.93 bar size is 16 and see, suppose if I change the property, suppose if I use 350 350 for all the columns, go to select beam parallel to y-axis, select all the columns and I just assign this size. Yes, remove the first one. Analyze, run analyze and see. Oh, yes, sure. How many?
Beams were also failed, no?
Yes. The same warning, I think 500.
So lower columns we are having 400 by 400 earlier.
Also,
So I think the column size should be minimum 0.4 by 0.6.
4.6.
400 by 600 minimum. It is 10 to it, na? It should be minimum. As 10 is
YD is about 6 mm, 600 mm, and
minimum
JT is
0.4, sir.
4.
Minimum.
And for last portion, last 4 or for whole column?
Sir, at this bottom 5 story.
5 story. Third, fourth, and fifth. Assign. Yes. Okay.
Phone problem.
It will do some warnings. No. Again, yeah, last one is failed, I think. And the total percent is 3.14. So we have to increase the size of the column. See, last one is failed now also. The second, first story, it will pass, but percentage of it still is exit 3.14. Bar size is 20 and bar number is 24. Oh. $16 1.90. So there is from 1% to 2% also exceeding column bar percentage. 1% to 2%. beam.
That we can do now. You can change the section one.
7 at 10 dia, 5 at 20 dia at top. These beams are filled. So if I give a 400 mm to a beam, select beam parallel to x-axis, select beam parallel to z-axis. Analyze, run analyze, then save this. We have to give a proper size for column and beam for height. See, it will reduce warning that now we have 100 warnings there. So we have to increase bottom beam and column sizes. So now see, at bottom, in top we have
So can I see
15
the
bar
percentage of steel in beam?
Percentage in which? In beam?
Yeah.
No, it will show only this. See, the section property, the plane, FI, FC, depth, width, and length. And if you want to view the result, click on the view result, go to result here, select the concrete beam, and see we have this detailing about beam number 1. These are the top and bottom um, reinforcement provided in this beam. Vy is 223 minus 0.0 Vy is 10. Support 659 mm away from start support. These are the reactions. 165 mm center to center, that we have two leg there at 10 dia. And see at last we have the result for total calculations. So we can't find, I think, but is there any percentage? No. Guideline 9 and 226 short column. These columns are filled. Column. Now I think beam is designed with 400 mm by 400 mm. We have to increase column size also, bottom column size. %93 is increased here. Okay, so see, tomorrow we'll see these buildings in STAT Pro, and here we have the some sections property also for column and beam. That is 500 by 500 mm, 550 by 550, then 600 by 600, and the beam size we have 500 by 300, 550 by 350, 600 by 40, and we have to use M20 concrete, and high strength steel we use 500, and for mild we use 250 river. Slab also we design slab that is 150 thickness with M40 grade, and in this we have auto draw cladding. This we use in ETAP, but in STAT Pro we use surface wall for cladding, and the load on the cladding is 0.2 kilonewton per meter, and we also have to calculate wind load considering parameter in Bangalore.
So what is cladding?
Cladding means it's a outside cover. This either it's a glass or it's a concrete wall. In ETAB it's called a cladding. It will provide a thick surface on outside to show us the effect of wind on the structure. So tomorrow we'll see this building instead.
So please share the videos to practice this stat, sir.
Yes,
Yes,
yes.
sir. Please.
I think they will uploading on the website. I think.
Pardon, sir.
In Cloud Campus portal, they have uploaded all the videos.